October 2025 is turning into a cosmic showstopper. Sky watchers across the globe are buzzing about Comet A6 Lemmon, a mysterious traveler returning to our skies after more than 1,000 years. It's not blazing like the great comets of history, but here's the twist. It's already shining brighter than scientists ever expected. And just as Comet R2 SWAN swings by for its own close approach, the timing couldn't be more perfect. For astronomers, this isn't just another light in the sky. It's a scientific jackpot. These two celestial wanderers crossing paths open up a rare window into how long-period comets behave when the sun starts cooking their icy cores. In this breakdown, we'll uncover exactly what makes A6 Lemmon's return so special, how it's heating up on its dive toward the sun, and what sky watchers should keep their eyes on in the coming weeks. The story begins back on January 3, 2025, when astronomer D. Carson Fool spotted a faint smudge while scanning the heavens with the Mount Lemmon Sky Survey in Arizona. That barely visible speck turned out to be a traveler that's been gone for over a millennium. Orbital data quickly revealed its secret. This wasn't some short-cycle visitor like Halley's Comet. A6 Lemmon takes a jaw-dropping 1,350 years to complete a single trip around the sun. Imagine that. Its last journey through our skies happened before telescopes, before modern history itself. But here's where it gets wild. After this pass, Jupiter's massive gravity is going to tug at it just enough to alter its orbit. That means the comet's next visit will come around a little sooner, in about 1,150 years. These subtle cosmic nudges are a reminder that even the biggest planets can bend the paths of these icy time travelers, reshaping their future courses across space. A6 Lemmon will make its closest swing past Earth on October 21, 2025, gliding by at roughly 0.596 astronomical units. That's about 89 million kilometers away. Then, on November 8th, it'll hit perihelion, its nearest point to the Sun, coming in at 0.53 astronomical units between Mercury and Venus. Unlike the short-loop comets that orbit neatly near the ecliptic, A6 Lemmon dives in from a steep tilted angle, slicing dramatically across the night sky. In early October, it slid under the Big Dipper in Ursa Major and now cruises into the western evening sky, visible low after sunset. Those who've caught a glimpse describe a faint ghostly green glow caused by carbon molecules lighting up under ultraviolet sunlight. That eerie color isn't unique, but it's a clear sign. This comet's waking up fast. It's shedding gas and dust quicker than predicted, and its brightness is climbing faster than early models ever hinted. Observers are already calling it one of the surprise highlights of the season, a quiet comet turning into an unexpected headliner. No, A6 Lemmon won't blaze across the sky like Comet Hale-Bopp once did. No naked eye spectacle here. But don't underestimate it just yet. Its steady orbit, unexpected brightness boost, and 1,000-year comeback make it one of the most exciting cosmic events of the year. Amateur astronomers and research teams everywhere are racing to catch every detail before it disappears again for another millennium. See, comets like A6 Lemmon aren't just pretty sky shows. They're literal time capsules from the birth of our solar system. These icy travelers have been chilling in the Oort cloud, untouched for billions of years, preserving the same raw material that once formed the planets themselves. Every time one swings close to the sun, it gives scientists a rare peek into the frozen chemistry of creation. That haunting green glow everyone's talking about, it's no random color trick. It happens when diatomic carbon C2 molecules in the comet's coma get blasted by ultraviolet radiation from the sun, causing them to fluoresce with that eerie emerald shimmer. By analyzing how much C2 and CN gas the comet releases, scientists can actually trace where it was born in the ancient solar nebula, and how its chemistry evolved while wandering through deep space. Even more fascinating is how its brightness changes as it warms up. Predicting a comet's light curve is one of the hardest challenges in astronomy, but early brightening like this hints that A6 Lemmon has volatile materials, ices and gases, activating earlier than expected. Every flicker of light tells a story of what's happening beneath that dusty crust. And the orbit? That's another piece of the mystery. Even distant encounters with Jupiter's gravity can yank a comet's path by millions of kilometers. Tracking A6 Lemmon's journey this season will help astronomers fine-tune models of how long-period comets evolve over thousands, even millions of years. This isn't just a passing visitor, it's a messenger from the edge of time. Finally, A6 Lemmon's growing coma and tail are turning into a live science experiment in the sky. Every puff of gas, every shimmer of light tells a story about what's happening deep inside that icy core. Any sudden flare in brightness or a twist in its shape could mean the comet's surface just cracked open, releasing jets of gas, or even breaking apart in real time. That's the kind of raw, unpredictable behavior astronomers crave. Watching these changes and comparing them to famous comets like 67P/Churyumov-Gerasimenko helps scientists figure out how different types of comets react when the sun turns up the heat. So no, this isn't just another faint blur fading into the background. A6 Lemmon's orbit, activity pattern, and chemical mix make it a goldmine of information for anyone studying long-period comets. Even if it never becomes a spectacle to the naked eye, its story is unfolding like a front-row lab experiment in the sky, and scientists are glued to every move. For sky watchers hoping to catch it, the sweet spot is mid to late October, about 45 minutes after sunset. Look low toward the western horizon because the comet won't climb higher than about 20 degrees, so any tall trees or city buildings will block your shot. Timing and location are everything. And get this, the timing couldn't be better. The Orionid's meteor shower peaks between October 20th and 21st, right when A6 Lemmon makes its closest approach. With a new moon darkening the skies, you could witness both a meteor shower and a comet in one breathtaking night. How wild is that? If you've got a decent pair of binoculars, you'll spot a faint greenish haze hanging over the horizon. That's the comet's coma. A small telescope will reveal even more detail, like a glowing head and maybe a short tail stretching outward into space. And for astrophotographers, this is a dream setup. Even short wide-field exposures can capture its delicate structure, and stacking photos from multiple nights will reveal its changing position and evolving shape. The excitement doesn't end there. Just one day before Lemmon's close pass, Comet R2 SWAN will be cruising by Earth too. Two comets, one sky, a once-in-a-lifetime double feature you definitely don't want to miss. And just when you think the sky couldn't get any busier, the faint interstellar object 3I/Atlas will also be drifting into view. For skilled skywatchers armed with bigger telescopes, this rare overlap is pure cosmic gold. It's not often you get to compare how two totally different travelers, one born in our solar system and one from beyond, behave under nearly the same conditions. Observatories around the world are watching Comet A6 Lemmon closely, measuring its light curve, tail structure, and orbital tweaks as it reacts to the sun's heat. Every bit of data gathered right now feeds into long-term models, helping astronomers better predict how distant comets act when they return from the frozen edges of space. These insights don't just explain A6 Lemmon's story, they help unlock how the entire Oort cloud population evolves over time. That's real cosmic detective work right there. Once it swings around the sun in early November, the show begins to fade. The comet will drift southward, slipping lower in the sky until it becomes visible only from the southern hemisphere. By early 2026, A6 Lemmon will vanish completely, beginning another 1,000-year voyage into the dark. A quiet retreat until it's called back by the sun again. So take this as your one shot. For nearly everyone alive today, this is the only time you'll ever see Comet A6 Lemmon lighting up the western sky. It may not roar with brightness, but its story, stretching across centuries, is breathtaking. So if the skies are clear, grab your binoculars, head west after sunset, and witness history in motion. And if you love rare cosmic moments like this, don't forget to like, subscribe, and stick around. We'll keep uncovering the mysteries of the universe, one story at a time. See you on the next one.